Okay. All mixed up. So, number 1, we already said this was mass to mole. So I'm starting with 5.23 grams of aluminum, and I'm ending with moles of sodium. So if I'm starting with mass and I'm ending with moles, I know this is a mass to mole stoichiometry. This is going to be 2 steps. So substance A is aluminum, substance B is sodium. Aluminum is A and B is sodium. So if I balance this equation real quick, I'll get a 3 here and a 3 here. All right, so if I go ahead and get started, 5.23 grams of A. What am I going to do first? 5 grams. There's only one thing I can do with grams. Convert it to moles. So in order to convert it to moles, what do I need? Good. You need mass, molar mass. So what is the molar mass of A? What's the mass of aluminum? Perfect, 27 grams. On my periodic table it says 26.98, but you can put 27 grams and you'll be fine. So that's equal to 1 mole of A. What's the next step? Mole to mole? So for every 1 mole of A, that's equal to 3 moles of B. So for every 1 mole of A, that's equal to 3 moles of B. Do I stop here? I don't. Well, what are we looking for? We're looking for grams of B or moles of B? All right, so when I solve this, I'm going to get moles of B, and that's what I want. I want moles of B. See? Moles of B. If I were to simplify the units like we used to do in first semester, grams of A would divide by grams of A and cancel. Moles of A would divide by moles of A and cancel, and I'd be left with moles of B. So pretty much whatever you're looking for in the problem, you should always see that unit in the upper right hand corner, and that kind of gives you a heads up that you need to stop. So when I calculate this out, 0.582 moles of sodium is my final answer. Any questions for that one? All right. Number 2. So number 2 says, how many grams of cobalt-2 fluoride are needed to make 1.95 moles of cobalt-2 nitride? So I find my number and underline that. That's where I'm starting. And then box where I'm ending. Cobalt-2 nitride is substance A. Cobalt-2 fluoride is substance B. So A and B. I balance half the equation in here, so 3 in front of the cobalt-2 fluoride, but we also need a 3 in front of the fluorine. And go ahead and write down where you're starting, which is 1.95 moles of A. So, when you write down moles of A tomorrow, and you're trying to think, where can I go with moles of A? Well, you have 2 possibilities. You can go from moles of A to moles of B, or you can go from moles of A to grams of A. Which one makes more sense? For trying to get to B, wouldn't it make more sense to go directly from moles of A to moles of B? Because we can, so that's what we're going to do. So for every 1 mole of A, that's 3 moles of B. So for every 1 mole of A, that's equal to 3 moles of B. If I were to solve this at this point, I would end up with moles of B, but I don't want moles of B, I want grams of B. So I'm going to take this one step further and convert it to grams. And the molar mass of B is 96.93 grams of B. And my final answer is 567.04 grams. Now, be careful when you're finding the molar mass of this substance. It's 1 cobalt and 2 fluorines added together. Do not distribute that coefficient into the molar mass. All right? Moving on. Number 3. Number 3 says, how many grams of fluorine are made if you start with 31.6 grams of phosphorus? So I can quickly see that this is a mass-to-mass problem. So I'm starting with mass and I'm ending with mass. I'm starting with phosphorus, grams of phosphorus, and I'm converting to grams of fluorine. So phosphorus is A, fluorine is B. This is mass to mass, so I'm going to end up having to calculate molar mass of both substances. So you can either do that in the problem or you can go ahead and do that in the beginning. I'm just going to do it in the beginning, write it down. So P, the mass of P for phosphorus is 30.97 grams. And for fluorine, F2 is 38, total of 38 grams. And if I balance this real quick, put a 3 here, a 3 here, and a 2 there. Alright, so 31.6 grams of A. If I convert grams of A to moles of A, 30.97 grams of A is equal to 1 mole. And then 2 moles of A is equal to 3 moles of B. For every 1 mole of B, it's equal to the mass, 38.00 grams. So once again, all my units cancel. Grams of A cancels, mole of A cancels, mole of B cancels, and I'm left with grams of B. If I simplify the number, you will get 58.1 grams of B. So number 4, we have to finish out this equation in number 4. So we have an element and a compound. This is a single displacement reaction. So plus, plus, minus. Switch the 2 positives, and we're left with Be and BeO, or Bo. So boron is a positive 3, and oxygen's a negative 2. So 2 and 3. And if I balance this, I'll put a 2 here, and a 3 here, and a 3 here. Alright, so we're starting with 6.27 moles of boron. We're ending with moles of beryllium. So I'm starting with moles of boron. So boron's A, beryllium is B. 6.27 moles of A for every 1 mole of A. For every 2 moles of A. That's equal to 3 moles of B. Final answer is 9.41 moles BE. And that's it.